Basic electricity, direct current. Number 3, ammeters and voltmeters. In the last program, you learned some of the symbols necessary to understand and draw schematic diagrams, and how to design and wire a simple circuit. Now in this program, you'll use that circuit and measure its current with an ammeter and its potential difference with a voltmeter.
Ammeters and voltmeters come in different styles, and they read results differently. In fact, a device like this multimeter actually includes the functions of both an ammeter and voltmeter. The meters you'll use have analog readouts. That is, the meters have a calibrated scale and a pointer needle that shows how much current or voltage there is in the circuit. If you used a digital multimeter, the readout it gives you would be the same information, but an actual numerical amount. In fact, it's the same difference you find between a digital watch and a watch with a dial. They both tell you the same information. The only difference is the way in which the information is displayed. In this program, you'll be using analog meters. First, let's begin with an ammeter.
An ammeter is an ampere meter. It indicates how much current in terms of amperes is moving through the circuit. The ammeter indicates the amount of current flow by the position of a pointer on a calibrated scale. The greater the current, the further along the scale the pointer will move. The maximum current an ammeter can measure is indicated by the highest number on its scale, which in this case is the bottom number, 5 amperes. Notice that the ammeter has a number of terminals to identify its polarity. Most electrical equipment is color-coded to make it easy to identify polarity. In this case, the single negative terminal is black, and the positive terminals are red. The ammeter symbol is a capital A inside a circle, with the respective polarity signs outside the circle. To measure current, the ammeter must be connected into the circuit so that the current flows through it from negative to positive. The schematic symbol for an ammeter always indicates the negative and positive terminals. Let's go back to the circuit and see how to use an ammeter to measure the amount of current flow.
The first step is to de-energize the circuit by disconnecting the power source or opening the switch. Looking at the schematic diagram, you can see it will be positioned between the switch and the lamp. Therefore, disconnect the wire at the lamp terminal that is connected to the switch. This will give you a place to insert the ammeter. Now, check the terminals on the battery and the terminals on the ammeter to identify the negative and positive terminals. Remember, the current flows from the negative terminal, and because the current must flow in the same direction throughout the ammeter, connect the negative terminal of the ammeter to the wire from the switch, which can be traced back to the negative terminal of the battery. In looking at the meter scale, you can see that the number 500 means 500 milliamperes, or about 1/2 of an ampere. The number 50 actually means only 50 milliamperes. The number 5 stands for 5 amperes, which in fact is the highest value this meter will hold. This circuit has less than 5 amperes. Therefore, connect the wire from the lamp to the terminal marked 5. Once all the connections are made, the ammeter is ready.
To find out how much current is flowing in this circuit, re-energize the circuit by closing the switch. If all your connections are good, the lamp will light again, and the ammeter will indicate the amount of current flow in the circuit, which in this case is 2.1 amperes. If there are any problems, check your connections. But first, make sure you open the switch.
Now, let's measure the voltage in the circuit. To do this, you'll use a voltmeter. Here's a typical analog voltmeter. The schematic symbol for a voltmeter is similar to the symbol for an ammeter. It's a circle with a capital V inside, and the negative and positive polarity signs on the outside.
To measure voltage, which is potential difference, you must connect a voltmeter across one of the items in the circuit that will act as either a source or a load. That is, you have to connect a voltmeter across a device that will show either a rise in voltage, like a battery, or a drop in voltage, like a lamp. Obviously, if there is no current flow, there is no voltage rise or drop. To begin, first, check to make sure the voltmeter can withstand the voltage you're measuring. If the voltage is too high for the meter, it will be damaged. Secondly, here's an important word of caution. When using any voltmeter, make sure you hold the meter leads by the insulated handles. Remember, the circuit has current flowing through it. Therefore, holding either the wire or the probe will make you part of the circuit, giving you a shock that could cause an injury. To set up the voltmeter, adjust the screw in the center of the meter so that the pointer is resting squarely over the zero. Next, connect the black negative meter lead to the black negative terminal of the voltmeter. Connect the red positive meter lead to the red positive terminal of the voltmeter.
Now, to use it, touch the black probe to the negative terminal of the battery. Then touch the red probe to the positive terminal of the battery. Look at the voltmeter. It's measuring the voltage rise across the power source, in this case the battery. It's reading 5 1/2 volts. That means the amount of potential difference is equal to 5 1/2 volts. Now let's measure the voltage drop across a load. In this case, the load is a lamp. Again, you must be sure to connect negative to negative and positive to positive. Note that the negative connection on the lamp is the post nearest the negative terminal of the battery. Conversely, the positive connection of the lamp is the post nearest the positive terminal of the battery. Always observe polarity when using a voltmeter. Once you've connected the voltmeter, again, look at the position of the pointer on the scale. It is measuring the voltage drop across the load in the circuit, the lamp, which in this case is 5 1/2 volts. Try measuring voltage across the switch. There's no reading because the switch is using no electrical energy. Therefore, there's no voltage rise or drop and no potential difference. Likewise, you cannot usually measure voltage between 2 points of the conductors. Remember, a voltmeter will only measure the rise in voltage across a power source or the drop in voltage across a load. If there's no rise or drop, there's no reading. If you are not sure how to use either a voltmeter or an ammeter, stop the program and review the procedures. The remainder of this program deals with some of the finer points of using both instruments, and you must understand the basics first.
Accurate meter reading, of course, is essential. The first step is to be able to interpret the values of the meter scales. Look at your ammeter. Its scale is divided into 5 major but equal divisions numbered 0 to 5. And each of these 5 major divisions is divided into 10 parts. Each small division equals 1/10 of the major division. With the pointer at the position shown, you can see that the value is less than 1. To interpret this reading, count the number of subdivisions starting at 0 up to the pointer. The correct reading is 8/10, or 0.8. When reading meters, always state results using decimals rather than fractions.
Using the same scale, let's take another reading. The pointer is between the whole numbers 2 and 3. Therefore, the answer will be greater than 2, but less than 3. Start at the whole number 2 and count the subdivisions to the pointer. There are 5 of them. Therefore, the answer is 2.5. In this reading, you can see that the pointer is after the 3 and between subdivision 2 and 3. In this case, you'd read this as 3.25. That is, any time the pointer is resting in between two subdivisions, you should read the number as 0.05. Here's another example, but this time you're reading the DC line on a multimeter. Here's where you'll be reading. It reads 4.7 amperes. Remember, always use decimals, never fractions. Take careful notice of the value represented by the small divisions on any scale. They're not all the same. On the voltmeter scale, the number divisions for 3 and 300 are easy, but the 15-volt reading is tricky. Each subdivision is really a 0.5 or half of a volt. Pay attention.
When connecting this meter to a circuit, you must first have an idea how much current there is in the circuit to be measured. If you think the current is going to be greater than 5 amperes, use another meter with a higher range. You'll damage this one.
To be accurate in reading any meter, you must position your eye directly in front of the meter scale. If you look at it from one side or the other, your reading will be inaccurate. For example, this reading looks like 6 volts, but if you turn the meter so that you're directly in front, you can see that the reading is about 5.5 volts. High accuracy meters have a narrow mirror along the scale to help you avoid this kind of inaccuracy, which is called parallax error. If you are not directly in front of the meter scale, the image of the pointer will be reflected in the mirror. Therefore, position your eye and the meter so that the mirror image of the pointer disappears behind the pointer itself. Now you can read the meter accurately. Let's review the material in this program.
Number 1. An ammeter measures the amount of current, or amperes, flowing in a circuit. Its schematic symbol is a circle with a letter A and the respective polarity markings.
Number 2. A voltmeter measures the potential difference or amount of voltage rise and voltage drop created by components in a circuit. A voltmeter will indicate 0 in a switch that neither uses nor provides electrical energy.
Number 3. Whenever you use a voltmeter, be sure and hold the test probes by the insulated handles. Also, whenever you open a circuit, as when you insert an ammeter, first de-energize the circuit by opening the switch or disconnecting the battery. Electricity can badly injure or kill you if you're not careful. Always take your time and pay attention when working with electricity.